So hi everyone, welcome to this session by Data Sense. So just to update, this session is going live on our YouTube channel. So you can watch the recording after the session is over as well. As per your availability. So just let me tell you, like a lot of you are joining first session of Data Sense. So we are a community. We keep on organizing various sessions on data analytics, right? From SQL, Excel, machine learning, data engineering, and all those topics. So this particular session is on the series of generative AI, where we will be teaching what is RAG, and it will be new for a lot of you people. Few people might have been doing this, so it's going to be an end-to-end practical project. So I advise if you guys can have your laptop, your any Python editor ready with you, maybe Anaconda, maybe VS Code or anything. So it will help you during the session. Please feel free to ask the question by typing in the chat box, right? And if you have any other issue, do let us know. So with this, I welcome Simran. So she will be taking the session. She's working as a software developer at Bosch Technologies, and she is she's very high on experience when it comes to teaching in machine learning and data science. So welcome Simran to the session. You can take forward from here.
Yeah, hi Satvik and hi everyone. Thank you for the kind introduction. Uh, okay.
Yeah, Simran, I can hear you. So yeah, you
All
can.
right. Great. Fine. Thank you so much for the kind introduction, everyone. I'm glad to see the participation here today. So let me quickly share my screen. Okay. Yeah, is my screen visible?
It's loading. Yes,
Okay.
I can see.
Okay,
If
great. Thank
anyone
you.
is not able to see, let us know. I can see your screen. Yeah.
All right, great. Thank you so much. So welcome everyone to the session. As you would be aware of that, this is about retrieval augmented generation. Today, I'm here to explain you about what exactly is RAG, retrieval augmented generation, which has recently gained a lot of, not only just recently, there are different techniques which have come up, and then it's a lot of hype around this word. So today, I'm going to help you understand how using this technology, how using retrieval augmented generation, you can build a conversational AI chatbot. So, by the way, I also make educational videos on YouTube. So here's my YouTube channel, CSE Insights by Simran Anand. You can check it out there. I'm currently working as a senior software engineer at Bosch Global Software Technologies, and I'm an AI and data science expert, have a flair for educating and mentoring people. So that was a brief introduction about me. So without any further ado, let's begin the session. Today's agenda, we are going to learn about what exactly is RAG. And before that, there is an important term called LLM, which is in the generative AI space. Everyone would have heard of this term at least, like ChatGPT. It itself is a large language model. So we're going to firstly understand what are the different types of large language models and the various prominent models which have come up recently. Along with that, what is RAG exactly and how can you actually build a chatbot using RAG? Some fine-tuning techniques to to enhance the accuracy of the AI chatbot, followed by generating code for RAG. We'll be understanding what is the retrieval part doing, what is the generator part doing in RAG, and how exactly can you even make a web UI or a front end. It always looks good that rather than just having the backend, you can also display the UI, a user interface, so that it makes it more interactive for you to actually build the application and you can interact with it. So let's begin the session. As I said, the objective here is to develop an AI chatbot that will engage in seamless, natural conversations. In the sector of customer service or conversational AI, it's very important to address queries that are with the chatbot does. But you might be already seeing that these large language models are trained on huge corpus of data. They have the tendency to hallucinate a lot. When I say hallucinate, they might be giving you responses which are not factually correct, but they seem to be correct. So it's something out of the context. We don't want the chatbot to actually give us responses which is out of the context. We want the chatbot to answer queries which is correctly matching the context. So how can we actually do that? Is by a technology, it's by the mechanism of RAG. So I'll come to what is RAG also. So this is what we're going to see, why we are going to build an AI chatbot. You can use any documents, by the way. We need a document database here for RAG, and we also need some source documents. Fetches relevant information from documents to answer user queries. So you as a user can prompt. You can write a prompt to the chatbot and expect the response, which is actually in the context. In this way, you're grounding the response of the RAG chatbot. The outcome is intelligent query resolution followed by enhanced user experience and data accessibility. So that is the agenda for today. I highly recommend you all to be attentive for this 1.5 hour, and also ping me in the chat section if you have any doubts. So before I come to RAG, large language model is the driving force behind it. It's the LLM. So LLMs, put in short, they are basically AI models which are trained on massive data sets to understand and generate human-like text. So you might be already aware of some data sets like DeepSeek model, which is gaining a lot of momentum these days. It's a very prominent model which can actually do reasoning also. There are different models like GPT 3.5, GPT 4, like ChatGPT. Then we have models like Llama, other open source models like Llama. Then we have Falcon model, Mixtral model. All these are various large language models which are trained on massive data sets, and they can actually generate us human-like text in the NLP space. So this is a brief about large language models. Some use cases.
Sorry to interrupt just a little bit.
Yeah.
Can you go a little bit slow? Few people are facing issue in catching up. So
okay, sure. We'll ensure that. So I don't know, some of you might be new to the technical field as well. So I was just explaining that large language models, basically, when you talk about LLMs, they are basically AI models. But unlike we training an AI model on data, they're already pre-trained models on huge data set. Right? So they're already pre-trained on huge and massive data, and we are actually using large language models in implementing chatbot, where we are going to actually do that with RAG methodology. So I've not started RAG yet, but it was a brief background about large language models. Some examples like ChatGPT, then you have Llama, Mixtral, etc. Some use cases of large language models. You might be thinking it's in the generative AI space. They are actually used in summarizing content, not only just generating. They can actually be used in text summarization, in answering complex questions, and conversing in multiple languages if they are actually multilingual. Some key features are they are context aware and scalability across domains. So these are the various use cases of different types of large language models. Now coming to what is retrieval augmented generation. All right. So retrieval augmented generation is basically, we are going to use it today to help make intelligent AI chatbots. So RAG over here consists of two main words, retrieval and generation. So we are going to augment when we say augment, we are actually increasing or improving the pre-existing knowledge of the LLM. Like I said, LLM or a large language model has some pre-existing knowledge. Why is it pre-existing? Because it is already trained on huge corpus of data. Now, if we want to actually enhance the pre-existing knowledge of the LLM by an external database, then we need a vector database for that to actually, or a document which whose embeddings will actually be stored in a vector database. So in such a way, when we're actually augmenting the retrieval and also enhancing the knowledge, pre-existing knowledge of the LLM, that is called as RAG. It combines retrieval of relevant documents with GenAI. For example, I give it a set of documents. I think the next slide will better explain it over here visually. You have some document over here. So how RAG actually works is there is a Word document, or it can be a PDF document also. There is a document. Now the entire document cannot be passed to the LLM, right? You need to break or chunk the document what you have into multiple chunks or multiple sections. So the content is firstly extracted from the PDF. There are various Python libraries which actually help in extracting the content from the PDF. So like PyNew PDF is one, which is basically helping to convert or to extract the text from any PDF document. So firstly, the text is extracted and it is chunked. So when I say the data is loaded, the document loading part is done, and then the extraction of content. Once the text is extracted from the PDF can be any PDF. You might be having a proprietary data PDF, or you can even use open source data PDF. So for example, you have passed that PDF, say a Word document over here. The text or the content is extracted, followed by the chunking part. Now, there are different strategies of chunking. To put it very simple, chunking is basically you're breaking the document into multiple subsections, right? And it depends on you into how many chunks you want to break your original document into. That is like a parameter which you will define while you're coding retrieval augmented generation. I'll also help you understand how exactly you can actually implement the document loading and the chunking part. So chunking is essentially when you are loading a document and breaking that document into multiple chunks. All right. So once you're done with the chunking part, you have multiple chunks here. As you can see, there are 3 chunks right now. But for example, you have set the chunk parameter to 10. Then you will be breaking the document or chunking it into 10 different chunks. Now, all these chunks will be actually, now you know that these chunks are actually documents. You have to vectorize them. So there is this embedding generation which is going to happen. And the embeddings for these chunks. What is embedding? So let me just check quickly the chat box if there are any questions so far. Sure, I'll do that. Example of multilingual part. So multilingual is basically any other language other than English, right? So there are some large language models which are actually trained on data sets other than English also. Okay, Google Translator for, okay, all right. So basically when I talked about embedding, so my question was, have you any idea about embeddings? Embeddings are basically numerical representations of text, because you know text or basically images are not understood by LLMs like we are understanding it. When we are actually passing a text or an image to a large language model, we actually have to, the LLM will actually only understand numbers. So there is this vectorization concept which comes into picture, which is along with the, not only just the encoding or the numerical representation of the token, it's also the semantic meaning is going to be retained. So the semantic or nothing but the meaning of the chunk will also be retained along with the numerical representation. So when the chunk, the embeddings are generated, all the embeddings have to be stored in a vector store retrieval, right? It has to be stored in a vector store retrieval. Now the vector store can be a vector database. For example, ChromaDB is one open source vector database. FAISS, which is FAISS or Facebook AI Similarity Search, that is also one of the vector database. You might have heard about what is a database, right? It's basically a space or a container where you're actually going to store all the embeddings. So we need a space, we need a database to actually store all the embeddings. So we are going to use ChromaDB, or you can even use FAISS. All right, so you can use all the vector databases to store the embeddings of the chunks. Now there is this vector store retriever component. Now, for building a RAG AI chatbot, there are multiple frameworks which are already available. Like, for example, the most famous one is LangChain. LangChain is an open source framework. Now, it's basically, it's like an orchestration framework, which is helping you to entirely, make an agent, or you can say make a application, a RAG chatbot from end to end. So when I say that, it has multiple components, one of them being a retriever. So retriever's role over here, like mentioned in the previous slide, it locates relevant chunks of data. Chunks of data over here are stored in a vector database. Now the relevant chunks of data are going to be retrieved or are going to be located by the retriever component of the RAG. I hope this is clear to everyone that what is the retriever component of the RAG doing. If there are any questions, you can ping it in the chat. Yeah, embeddings are numerical representations of text, absolutely. Along with that, the meanings also are retained. The semantic, not just the numerical representation, along with that, the semantics is retained, right? With the context. So the context is not lost. Now, when I said it is actually stored in a vector database, there is a retriever component, which is actually helping to locate the various relevant chunks of data. Now the word over here is relevant. It's very important that when we as a user are prompting the LLM, we have to ensure that the kind of responses which the LLM is giving is not something out of context. We want the chatbot to actually, locate us the relevant chunks, something which is very coherent, clear, and also in terms of relevance, it should be something which is in the document. You have passed a document over here. But what if the chatbot is giving you a very generic response? Maybe you have a document which is talking about deep learning. But then if you ask a question, something related, which is there only in the document, but it is giving a very generic response, which is not there in the document. So it is kind of hallucinating, or it's kind of using its pre-existing knowledge. But we want to curb that. We want to actually ground the responses of the chatbot such that it gives us relevant responses from the document. That is where RAG comes in. All right. So that is also one of the techniques, I would say. It is cheaper than fine-tuning techniques also. That's why RAG is more preferred. And there are a lot of variants of RAG also which have come up due to its nature of simplicity, flexibility, and it's also helping us to ground the responses of the AI chatbot, making them more intelligent so that the context or the relevance is not lost. So this is the retriever component. Now, for the vector store retrieval will retrieve the relevant chunks. And then once we as a user asking a question on this side, where we as a user asking a question, our question will actually be in a string format. It has to again be converted into a number format. Like you just rightly said, it's a numerical representation. So we are actually generating a query embedding. We are passing a query or a question that is in the form of a prompt. And then the query embedding is generated over here. From the query embedding, a semantic search is followed. So semantic search is a major, I would say, major concept which is driving behind this technology. What is happening is it will actually now find a dot product, the closest vector. We have a vector database where we have all the embeddings of the chunks, and we have the query embedding from the user. Now, what is the closest embedding, chunk embedding from the document, which is actually closest? When I say closest in space, it is closer in meaning, and it is the most relevant one. So for actually retrieving the most relevant chunk embedding or the response for the query embedding, we need to do a semantic search. So semantic search is essentially like, you can say, a semantic similarity or a cosine similarity technique. In mathematics, you might have heard of this cosine similarity, right? It's a dot product between two vectors. So when do we say in mathematics that two vectors are, when two vectors are very similar to each other? We say two vectors in mathematics or in linear algebra, two vectors are similar to each other when their dot product, right? They should have so when we can say that they are more close in space, right? So when you actually do that, the semantic search will find the most closest vector, whichever is closer in proximity, that is the most similar in nature also. So the vector store retriever will retrieve the relevant document embedding, or you could say the chunk embedding from the vector database after the semantic search is followed, and then the closest results are returned here. Now from the closest result, we have only done the retriever part. What about the generator component? We have seen how the retriever is working over here. The generator component is going to use that retrieve data, whatever the vector store retriever has given us, these close results, for the answer generation to be sent to the user as a response. So that is where the generator component comes in. It is going to use the retrieve data to craft accurate responses. So we know that LLMs actually have their pre-existing knowledge. So to enhance further their generation capacity, that is where the relevant responses from the retriever document, there is an inherent re-ranking which is done. So what happens is, though the closest results are returned, for example, there are some top 5 results which have been returned by this vector store retriever after doing the semantic search. Now, among those top 5 results which have been returned, which is the most closest, which is the most accurate to be sent to the answer to the user? Because we cannot definitely, the LLM will not send you 5 answers. It will only send you top most closest answer, or the most relevant answer. So that is where the answer generation or the generator part comes in, which will use the retrieve data, do the re-ranking concept there, and then give you the accurate responses. By the way, since I was also talking about the chunking, right? So in chunking, there are other hyperparameters also in RAG. Along with the number of chunks, there is also an overlap parameter. Because one natural question which might come to your mind is, when you're actually chunking a document, you're breaking the document essentially. Now, there are certain ways in which you can do that. One way is the most random way, that is by using a recursive text splitter. So once you have extracted the text from the document, you can recursively break the text into multiple by using a recursive text splitter. That is random splitting. But in that way, what if your document is quite complex? Your document is not just separated by spaces, but it is separated by, say, a citation, sort of tabular data is there in your document. For example, in legal documents or in, say, research papers, over there we see tables. It's not that easy to chunk randomly. So there are different chunking strategies as well, which you can look into, and I will also be showing you that. So the most generally, we can say recursive text splitter works quite well. That is one way you can do the chunking part also. So like I said, the chunking strategy is important over here as a way to enhance the performance of the RAG chatbot. And then another way is the number of chunks you want to divide. Then the overlap size. Because you are chunking your document, there should be some offset value or some overlap between the chunks, right? So that overlap value, the size of the overlap, can also be decided by you while chunking. All right, so these are all the hyperparameters which you can actually fix and check, experiment with various ones for your document, depending on the complexity, how the actually the chatbot is giving you intelligent responses. So that is all about the generator component over here. When I was saying, and the advantages of RAG over here is firstly, it enhances accuracy. Definitely you can think of like when you have a chatbot, right? And it is not hallucinating. It is not giving you something which is out of the context or out of the document you have. You can also frame it in the prompt. Some people might think that we can go for fine tuning. I can say that if you want to further take your RAG skills to the next level, then you can go with fine tuning techniques also. That way you can enhance the performance. One simple approach is prompt engineering. So prompt engineering is basically you're refining, you're actually giving some example. You can give some examples also in the prompt. The more clear and the more concise, I would say more prompt in the descriptive prompt you make, it is better for the LLM to actually get the context, right? So that is also, that comes in prompt engineering. I'll come to that slide as well. So it enhances the accuracy. That is one way. Another is dynamic context-driven responses. Context-driven is very important because it's from the context of the document where the RAG is actually, the RAG chatbot is actually giving you the responses. If in the prompt you actually mention that if the answer, if you do not, you can prompt the chatbot, right, like that if you do not know the answer or it is not there in the document, please do not make up the answer or say, I do not know the response. So in that way, if you instruct the prompt, you're actually guiding the prompt in such a way that it is actually giving you tailored responses. It is aligning with your requirement, right? So that is also one way in which you can actually enhance further the accuracy of the RAG. But that comes in the later stage. I think for now, you might be already clear with this concept of RAG. If there are any questions, you can let me know in the chat. I hope it is clear for everyone. All right. I see hand raised. So if there is a doubt, you can ask me in the chat. Or Sayak, do you have any doubts? Okay. All right. Then we can continue for a while.
Hello.
Yeah. I think someone's mic is open.
Yeah, I will fix that. Don't worry. You please carry on.
Yeah, sure. All right. Then now retrieval, this is all about the concept of RAG. Now coming to example, right? If you, instead of giving vague responses, it is actually providing direct answers pulled from your document response repository. This is very important. That is the purpose why we are actually going with RAG. I hope this actually made you understand what is the methodology behind RAG. This is the diagram which actually explains how RAG is working, like I said, and also the various strategies you can follow, some examples of document databases. Now for RAG, what exactly do you need to implement all this for getting the answers from the document being pulled, right? The answers pulled from the document. What exactly is the requirement? I would say this prerequisite is a little knowledge about LLMs, large language model, because as I said, LLM is the driving force behind any AI chatbot in the Gen AI space. So the type of model you're using will also affect the quality of the responses, the quality of responses you're getting. But I hope you have understood how it is differing from a simple AI chatbot. A simple AI chatbot is not firstly using probably LLM if it's not a Gen AI chatbot. If it does not have the document along with the document database or any orchestration framework like LangChain integrated, in that way it won't be actually having access to the vector database. Along with that, there won't be any access to any external document. So having an external document or any external knowledge base is very important. It's also one of the components of RAG. Also, an example, like I said, LangChain, it will have multiple components. There is a very interesting component called as memory. So memory module, what it does is, like just in ChatGPT also, when you're actually prompting ChatGPT, you see that the conversation history is actually saving whatever the context is, right? With your previous and past interactions, everything is actually saved in the conversation history or in the memory component of the chatbot. Similarly, in the RAG process also, in the LangChain framework, we have the memory component doing that. So that is additionally very beneficial because that will retain the context. For example, I was talking about deep learning. And if I give it a follow-up question, which I need not again repeat my previous query, I can just follow up from the previous query only. It will take the previous context as the background information, as the backstory for generating a response. So memory, not just for RAG, but for any LLM models or for AI chatbots when you're building, is again a very important factor. All right. Now coming to tools, like I said, now you might be thinking like, are they only documents which can be, given access to the LLMs, or can we actually link the LLM with tools also? Definitely you can do that. You can use web-based search, or you can actually connect multiple tools. Like say you want Wikipedia API, or say 𝗪𝗫𝗁, or you want to connect web-based tools also. For web-based search, you want to actually connect that to the large language model to enhance its pre-existing knowledge. By giving large language model the access to not just database, not just vector database, or not just document, but also to tools that will further enhance the performance of the RAG chatbot, because it will give it more capability to actually think and give the response. So that is where, slowly the agentic era also had come in, and there is a lot of hype around this agentic RAG. So I'll also show you, there is time, I'll also show you about how agentic RAG is working, where you can also connect multiple tools over there to your chatbot. Firstly, let's understand the basic flow of RAG chatbot, how to build it. I hope this is clear for everyone. If there are no doubts in semantic search, answer generation, retriever, and generator component, then we can move on to the next slide. Okay. Apart from going the theory, yes, I'll be covering the live very soon. Yeah. Now, I have already explained like why RAG is a game changer, right? Because it combines retrieval of accurate, up-to-date information with the generation capabilities. LLMs definitely do have generation capabilities. But what about the retrieval part? Retrieval is something which is actually augmenting or boosting the performance of the LLM's generation capabilities. So it actually helps. What if your document keeps on changing? If your document has some records which keep on changing, or you want to update the knowledge of the LLM, it is very helpful here, because it is helping the LLM to be up to date with the information from the external sources. It provides context-aware responses by grounding answers in real-world, domain-specific data. Definitely, if your data of your PDF document, any data which you're actually connecting your LLM model, the chatbot to, that is also domain-specific. For example, you can build a mental health chatbot. That also can have some data which is related to domain-specific, something related to mental health. Right? So that is one example where you're actually grounding the answer to your domain-specific data. You need not approach the fine-tuning part of it, because fine-tuning is expensive, computationally expensive than RAG. So this is also one of the ways to actually enhance the performance. It ensures precision, reduces hallucinations, enhances trust in AI outputs, right? Because it is grounding the responses. Definitely, as a byproduct, we can see enhanced trust. RAG is versatile for turning static data into actionable conversational intelligence tailored to your needs. Fine-tuning, I think I can come to this slide later on. Like I just said, the focus is on RAG, but these are different ways in which you can actually enhance the model's performance by doing domain adaptation and parameter freezing, where you're not actually retraining the entire model. You're just training a part of the model. You're customizing or adapting the model to your domain-specific data. In simple words, that is what is fine-tuning. Now, parameter freezing is you're actually freezing the pre-trained model's weights, the first few layers, and the last few layers are the ones which you are retraining. So that is what fine-tuning does. And there are different ways to do that, like low-rank adaptation or quantization, quantize QLoRa, etc. Now, generating code for RAG, you can actually, if you're someone who's coming from a non-technical background, over here I have added that as well. You can use tools like ChatGPT or code generation tools, because they are also helping for RAG templates if you're someone from a non-technical background. But anyway, in this session, I'll be covering and explaining you in depth how the code works, each of the line. And the key steps are you're actually defining the retriever. Like if you want the vector store retriever, if you want to go with ChromaDB, Elasticsearch, FAISS, all these are vector documents. You can use pre-trained models or any LLM for text generation and combine both into a functional RAG pipeline. So yes, that was all about the flow of RAG and how exactly it is working from the document loading, chunking, embedding part generation, vectors towards semantic search, and finally the generation capability. Then prompt engineering, I hope this is also one of the technique wherein there are different types or ways in which you can actually specify the requirement or the prompt. So prompt is basically the requirement you're specifying to the LLM model, right? So in a way in which you want to guide the AI for the desired response. The more elaborate you make it, the more examples you give it in the prompt, the more descriptive or more understandable it will be for the model. So when you say zero-shot prompting, it's where you're not giving any examples. No examples are given or no sample data is given over there while in the prompt. You simply provide your requirement without specifying any sample inputs. But whereas in a few shot prompting, you actually kind of provide a prompt template. What are the sample inputs you are looking for? So it will act as additional examples, additional training examples for the LLM. So that is also one way to improve the performance of your model, which is few shot prompting. One is one shot prompting. One shot prompting is instead of giving few examples, you're just giving one example. Chain of thought prompting. This is also very helpful and handy type of prompt engineering because it is actually enhancing the LLM's responses. The LLM will actually decompose your problem into a step-by-step format and it will reason step-by-step. So it is like step-by-step reasoning, which is called as chain of thought. Like for example, I give you a mathematical problem to solve. Then you will be breaking, like just like we as humans, we break down the problem into multiple sub-problems and then we think step-by-step. We tell the approach. We don't just give the answer. We step-by-step solve the problem. So that is also can be done by chain of thought prompting. Now to build a web UI at the end, I will be showing you through frameworks like Streamlit. I hope you might be aware of this framework already. It's a pretty common framework. It is a low-code framework also, I would say, which is basically Python-based UI development. Or you can go with Gradio also for simply prototyping or bringing your AI chatbot into picture. All right. So this is how chatbot looks like, wherein this basically is the overview of what I'm going to show you right now. So a document query system where you just pass a PDF document, and then after you pass the PDF document, say I passed an environment pollution document, I ask a question related to that document, like what are the causes of pollution? It starts giving me the answer from the document. Definitely it's going to use its existing knowledge also, but it will also give us the grounded response from the document. Right, so this is an example, and this has been built in Streamlit. It's like a UI where you can upload your files as well. I'll be showing you that. Then the workflow is to develop the backend with RAG pipeline, enhance further with, you can say, prompt engineering for now. Let's not go with fine tuning, and integrating with a user-friendly web interface like Streamlit. Here's an example of Streamlit again. If you want to try out, like I said, LangChain is one framework. You can do with Llama Index as well, and you can just customize the UI and see how exactly it is working. So this is how exactly the benefits of RAG. It is used in customer support, knowledge management, education and training, and research assistant. So that was about it. Let me now that the theory is done and you have understood RAG, let us now start building RAG. I just hope everyone over here has Visual Studio Code. If someone does not have Visual Studio Code, let me know. Or you can have Jupyter, you can have Anaconda, or you can even go with PyCharm. Any ID would work. FAISS and ChromaDB can be used for free. More than VectorDB, the decision should be which embedding model to be used. Absolutely, yeah. Embedding model is definitely very important because that's where the quality of the responses also depend, and also the database. So these two are very important. Okay. All right. Now coming to, I will just quickly show you on Visual Studio Code. Just a second. So in this code, basically, I have different variants over here, which I've just executed. One is through agentic RAG, and one of the code is basically I have built a very simple, RAG-based chatbot, wherein I'm going to show you step by step how can you actually start with the chunking part, document loading, chunking part, and followed by the other components of RAG, like the retriever and the generator part. So firstly, you have to import all these necessary libraries in your system. So we have two files over here, RAG pipeline.py, where I've written the backend code, and I have RAG UI.py. For now, it is just these two, RAG UI.py, where I have written where I've actually built the UI for my RAG chatbot. So this is the, in case you require these files, I can share it to you towards the end of the session. For now, firstly, you have to import these requirements, which is importing OS, NumPy as NP. So firstly, now you might be aware of these by NumPy. NumPy is basically numerical Python used for any kind of mathematical calculation you do. Import FAISS. So FAISS is a vector database, which I'm going to demonstrate over here. Facebook AI similarity search. It's also open source. From now, before I jump into this, you need a Grok API key. If you want to use an OpenAI model, you need an OpenAI API key. But for now, I have used Grok as the, because I want to do faster inference, right? Faster inference on the cloud. So for now, you can go onto this site called Grok. Basically, it is helping you to do faster inference for LLM models. And these are all the supported models we have in Grok. So you would firstly require a Grok API key, and you can go to the API section in Grok over here. Yeah, it needs some authentication, but I can just share you this link in the chat. I would request if you're going with models. So Grok is a very for faster inference, like I said, platform. So here's the link for accessing the API keys. You just need to create an account. And once you create an account, you can actually access the API key. Then you have multiple supported models over here in Grok. Like we have Digital Whisper Large 3, Gemma model, Llama 3.2, 3.1, and Llama 3 70B. We have Mixtral model. So, and some of the preview models also. Now, also one interesting note, you might have been also hearing a lot about DeepSeek models, right? So here it's in the preview stage right now. But if you want to actually see how DeepSeek is also working in your code, you can actually make use of Grok API key right now, and then just provide this model ID in the code. I'll show you where exactly you can just change that model name. You can just change it to DeepSeek. So why DeepSeek is because, firstly, a Chinese company named DeepSeek has come up with this model. It's a very powerful reasoning model which can solve aptitude questions. It can also solve coding questions on very benchmark data sets, and it is also cheaper than OpenAI, right? So due to that, it is gaining a lot of momentum, and also it's helping for solving coding questions, mathematical questions, like I said, and also has a reasoning capability. All right, so if you want to explore a little about DeepSeek, you can just type your DeepSeek. And it just says it says start now. You can just log in over here. Once you have logged into DeepSeek with your Google account, or you could just create any ID, this is how the interface of DeepSeek looks like. So you can actually ask a question. What I was saying is DeepSeek actually has this think component and the search component, which is the web. It can actually have the capability to search the web when necessary. And it is deep think model, which is actually able to actually solve the reasoning problems. So you ask it any mathematical question, like can you solve a particular expression? It will actually do step-by-step reasoning. I can show you a quick example, like can you solve this expression? Just for knowing the capabilities of this model. So if I just say any mathematical expression for now. Now the kind of response, if I just go to deep think, the kind of response it is giving is all step-by-step. You see, first it's saying division. It's actually step-by-step reasoned out the problem, and it's actually giving me a correct response. So it also has this parameter called deep think and a web search. So in case you want to actually paste a link over here and wanted to do some web-based search, that is also possible in DeepSeek. So you can actually explore this LLM model if you're not aware of it yet. Otherwise, there are plenty of models, like I said, on Hugging Face Hub platform, which you can use for building your RAG-based chatbot. And you can also have a look into the supported models of Grok, because currently we are going with Grok API key. So once you are ready with the API key, what you have to do is just create a .env file. A .env file is basically called as an environment file, where you are actually storing any confidential information, like say tokens, any large language model tokens or API keys, etc. So right now I have my Grok API key, which I have pasted in .env. So you have to also do that, and like I see, Grok _ API _ key equal to the API key. All right. So that is how exactly you have to capture the API key and present it. Grok API key equal to, and then you have to assign the value of the API key. Once you're done with that, now coming to the backend logic, where it's the RAG pipeline.py, you have to import these libraries: OS for interacting with the operating system, then NumPy as NP, which is an alias. From .env, import load.env. Why? Because this is basically going to help me to fetch my Grok API key for giving me the access to the model, right? Then from sentence transformer, import sentence transformer. I have used this particular library because as you might know, there are different ways of generating, embeddings, and there are different embedding generation models also. One of them being sentence transformer, another is Hugging Face embeddings or OpenAI embeddings, whichever works for you. Right now, I'm using the All Mini LM L6V2 model for actually generating the sentence transformer embeddings in my case. Okay, this also pretty much works well, but as I said, you can actually go with some other models also for generating, like Hugging Face embeddings, or if you want, OpenAI embeddings. From Grok, import Grok. So this is basically because we are using the Grok library. I have to do that. Firstly, you have to install all these requirements. You have to install. Yes.
Yes. Can you go a bit slow, please?
Sure. Arun. I'll do that. In case you have any questions,
theory part is fine, but when you're going to programming, this is very new for all this. Libraries. All. Can you go a bit small? Slow?
Sure. We'll do that. Yeah.
Thanks.
I hope everyone has created the API key from Grok. Can I get a response? Grok use. So Grok is basically for faster inference. All right, you have created the API key. Yes, requirements.txt. I will do that. Now, what exactly is, if you want a little overview of Grok, right? It's basically, sometimes we actually train models locally, but that takes a lot of time, right? And it also takes a lot of GPU also. What if you don't have GPU in your system? In that way only, to make it accessible so that everyone, even those who have a GPU constraint, I have gone with Grok platform so that you can easily train models, not locally, but on the cloud for faster inference. So that is the use of Grok over here. And these are a quick start, you can actually have a look how to create an API key. I'll share the reference docs over here. How to create the API key, I've given that link over here. You just have to go to the API section, create an account, go to the API section, and then create the API key. Then you have to have a .env. In .env, paste the Grok API key. Just say API_key equal to, or say Grok API key equal to, paste the Grok API key you have just generated. Now, someone was also asking the requirements.txt. For now, you can, I would request you, I am not sure where the requirements.txt is there, but then for now, just exactly, I would say you just need FAISS, FAISS, you need sentence transformers, anything which I mentioned over here in the import, right? You need that. So I'll just say you need Grok firstly, you need sentence_transformers, then you need FAISS and NumPy. And FITS model. Now, so FITS is basically for PDF processing. You remember when I was saying that the PDF document is going to be loaded, right? You need some processing. You need the extraction of content from the PDF to be done. So that is done by FITS library over here. Or you can even use PyNewPDF. That is also one way in which you can do the PDF processing. So if you want, I will just write it in the chat over here. So firstly, FAISS is Facebook AI Similarity Search. It's a type of vector database for storing all our embeddings. So firstly, you need FAISS. Then you can also install LangChain, because in the other code I have used that. So LangChain Grok, I'm typing it in the chat. Then you need Grok. You need NumPy as usual. Then you need pandas. These all should be there. Then FITS, and I think there was one more, sentence transformers, right? Sentence_transformers. So for now, just install all these libraries, and I hope you know how to install these libraries. Firstly, you have to create an environment. You have to create an environment over here. So in my case, I've already activated my environment env, but how to create an environment? It is Python-m venv, and then you give the name of the environment. So if in my case, it is env. So you can also give any name to the environment, like let's say chatbot. This is the name of the environment. Once you have created your environment, you can activate the environment by just saying chatbot and then scripts activate. It depends on the operating system also how you're using. But then for now, just create the environment, activate it, and then do pip install. Pip install, and then the library. So example, I want to just say, for now, I'm saying pip install NumPy. NumPy is already installed, but then for now, just a quick demo. You can say pip install NumPy, and then don't have to do it one by one. You can say pip install FAISS, LangChain, Grok, everything with a space. Okay. So I hope you have installed these. How can we use this Grok API key in Google Colab? Can you please tell me, because I don't know. Okay. So basically, you can do that in Google Colab also. I would recommend you to go with VS Code, PyCharm, or something locally in your system rather than going with Google Colab, because we are also going to build the UI part, because you want to make it interactive, right? In Google Colab, only the backend can be coded. But then if you want to use Streamlit, then that is a bit difficult. So that's the reason I would recommend you to go with anything in your application in your system, maybe Visual Studio Code, PyCharm, or Jupyter Notebook in Anaconda. Otherwise, if you want to use in Colab, there is a way called API, like, secret tokens are there. There is a secret token key section in Colab where you can actually mention API key equal to and paste your Grok API key. Okay. For the backend, you can code in 𝗏𝗏, but then the front end, I don't, I don't think you can actually see the front end over there in 𝗏𝗏 if you're using 𝗏𝗏 as your environment. Okay, and yeah, as I said, Sakshi, you don't actually need to worry about GPU because we are using 𝗏𝗏, right? And 𝗏𝗏 is doing the inference. It is doing, the reason why I have gone with 𝗏𝗏 is because it's going to do faster inference on the cloud, on the systems which are on the GPU, using the GPU inbuilt of 𝗏𝗏 itself, and it is completely free. That's the benefit. So that's the reason I would recommend you can do it locally also. Even if you don't have a GPU enabled system, that is completely fine. You can actually do it locally, but all you need is Python installed firstly. Everyone should have Python 3.8 to 3.12. That anywhere between that is supported. 3.13 is not supported right now because we are using sentence transformers libraries. It is not might throw compatibility issues as well for you. So 3.8 to 3.12 is the Python requirement for this building of the RAG chatbot. And yeah, these are the libraries.
Just I will like to interrupt once.
Yeah.
If you want to use Google like this API key with Google Colab, there's an option where you can enter the key secrets if you have opened Google Colab, right? Again, that is not in the scope of this session. Here we will do things on VS Code only, but in Google Colab, you see an option where you can enter your passwords, your API keys and everything, so that you can.
Yeah,
again, yeah, you can just show once, but let's focus on VS Code part for mainly.
Correct. Yeah. All right. Okay.
So like
so
if you just
want to, yeah, this I can show you this
if you
section.
See there's a key option in the left.
Right.
Just go back. Yeah.
Yeah. This one.
Yeah. Here you can enter your any key you want to, and just name it and put the value. So your codes will automatically have access to that.
Right. I hope that answers your question. Right. So this is where, even I was using Google Colab for the backend, I had given my key over here, OpenAI key, and I've given the value here. So it's another key, if you want to add, you can just click on plus add new secret. All right. So I hope that answers your question. Now coming over here in the backend code, where I've given you the requirements, right? What you have to install, the libraries in the chat. So I hope everyone has installed those, or if it might take some time also to install, that is completely fine. Once you're done with that, load env. So if you want to load your environment key, in our case, it's a 𝗏𝗏 API key. You have to write load_.env, and 𝗏𝗏 API key is equal to os.getEnv of 𝗏𝗏 API key, because 𝗏𝗏, now this is customizable. This is what I have given as the variable name for storing my 𝗏𝗏 API key. In the .env file, I have given 𝗏𝗏_API_key equal to, and I have pasted the 𝗏𝗏 API key. That's why this is the name for that. In your case, if you have given API_key, please give API key here. All right. So whatever name to the variable you have given in your .env file. So that is what you have to do. Okay. So once you have loaded that, and this is also very important, this is how you are loading your environment variables, then initialize the 𝗏𝗏 client. How are we actually initializing the 𝗏𝗏 client? We are simply saying 𝗏𝗏 client equal to 𝗏𝗏 of API key equal to 𝗏𝗏 API key. So this is the code to initialize the 𝗏𝗏 client. Once you're done with this, API key is 𝗏𝗏 API key is storing the API key of yours, which is fetched from the env file. So I've just assigned that to the 𝗏𝗏 client. Then I'm initializing the sentence transformer, which is all mini LM model. Now there are different embedding generation models. Like I said, one of them being sentence transformer embeddings, which is by the all mini LM L6v2. It's also open source and free. You can, if you don't know this model, you can go to Hugging Face Hub also over here. Any model which we encounter and you don't know, I would recommend you to go to Hugging Face Hub and have a look into why they are using that model also. A little description of that. So Hugging Face Hub. And go to models. And you can just search in the name of the model over here. Should work. Yeah. So as you can see here, sentence transformers, all mini LM v6. This is the exact model, what I'm using over here for generating the embeddings. All right. Then coming over here, if you want to have a, like this is for any model, if you want to actually have an understanding how to use a particular model, click on use this model and go to transformers. You can have a snippet over here into as to how you can actually import the auto tokenizer or the model into your workspace. Okay. Now, once we have this, and we are initializing the sentence transformer model over here by passing the mini LM v6 model, then this small function I have written for document loading. Like I said, there are 5 steps in RAG. First is document loading. So I've just encapsulated my logic inside this load document function. What is it doing? Defining the function load documents, passing a file over here. I've passed a file, and then I'm checking if file.type is application/PDF. That is, I'm checking firstly if it is a PDF file or not. Why? Because like I said, FITS library, what I'm using is for PDF processing. So if the document is not PDF, it would not work for now. But you can definitely go with some other document also. For now, I'm checking if in this logic, if file.type is a PDF document, it ends with .pdf. Then PDF loading, I just assigned a string value to text over here because I'm extracting the text from the PDF. For as of now, this is what to be returned, but for now I have initialized to an empty string. Then PDF document is equal to fits.open of stream is equal to file.read. I'm actually reading the file over here and then storing that in PDF document. Then I'm iterating over all the pages present in that document. What if your document consists of multiple pages? You have to first loop over all the pages. So that's what I'm doing here. Simple function where I've just written the logic for page number in range of PDF document.page count. Page count will actually give me the total count of the pages present in the document. Then page is equal to PDF document.load page of page num. Load page is actually going to load each and every page present in the PDF document. Text plus is equal to where I'm just appending to my empty string. I'm going to, I can say I'm just concatenating it. Page.get text of text, where whatever the text is extracted from. So this is an inbuilt function, by the way. It's a predefined function for the library. Page.get text and load page. So load page is going to load the page, and get text method is actually going to extract the text from the PDF. Then return text.split lines. If you want to actually split the text what is extracted from the PDF, you want to split it by lines or by new lines, that is by /n. You can actually use split lines also as a function over here. Else, that is for text file. So I've written a logic over here in the else part that in case your document is not PDF, it is a Word document or a text file, then I'm going to say return file.getValue .decode UTF-8.splitLine. So this is the code which will handle the logic in case it is a text file. I hope this is clear to you. The very first component what we have discussed, that is document loading. All right. Anyone, any questions in the requirements or any? I hope the libraries are all installed and set up. I can share you this file as well in the chat. So do let me know. Okay, great. Yeah, in case it is working, then what you could do is you have to define embed documents of documents. So basically, now the next step over here is a function to embed the documents. Once you have the documents loaded, we definitely have to embed those documents using sentence transformer library. So I'm writing over here a function called embed documents, where embeddings is equal to model.encode of documents. So encode over here is basically to encode or to convert the documents into a numerical representation format. So I've done that over here. Return np.array of embeddings. So over here, it's going to return me a numpy array of the embeddings generated. Once this function is also completed, then I have the build RAG pipeline where I'm passing in the documents. It will take the argument as documents. And then the embedded documents, I'm using a function over here, embed documents, which I've just defined above in this embed documents code, where I'm passing in the documents and then going to embed those documents using sentence transformers. Then I'm going to initialize FAISS or FAISS vector database for efficient similarity search. Like I said, a very crucial component of RAG when you're building the chatbot is semantic search or cosine similarity. It is quite intuitive because in vector algebra or linear algebra, you might be aware of that any two vectors or two words which are close to each other are more similar. Same way I'm going to do that embedding. I'm going to actually use FAISS for doing the retrieval part. DIM or the dimension, the embedding dimension I'm going to extract. So embedded documents, docs.shape square bracket 1, which is basically I'm accessing the embedding dimension of the embeddings which are generated. Then index is equal to FAISS.index flat L2 dim, which is going to extract the index. So this is basically for efficient searching. We add indexes. There's a concept of indexing in documents, which is basically for efficient searching and retrieval. So index.add of embed docs. Once you have added this to the index, the next part is a function for querying RAG pipeline. Over here, there's a function df. I'm just define the function RAG chain of query. model.encode of query. Though you know that once also the document embeddings are generated, it's very important that the user query also has to be embedded. Like I have shown you in the slides also, that there is this concept that over here, when I show it to you, that along with the, not just the chunk or the document embeddings, also the query embeddings have to be generated, right? So that is what I'm doing over here, model.encode of query. The query is converted into a vector format. Then I'm retrieving the similar documents using FAISS, which is similarity search algorithm, which I'm applying. Distances and indices is equal to index.search of query embedding, and then the top 3 embeddings. I want to return the top 3. K equal to 3 indicates that the top 3 most closest results are going to be returned. Then retrieve docs is equal to the most retrieve docs is nothing but the most relevant docs which have been returned by the retriever component of RAG. So the retriever component of RAG has actually returned us the top 3 documents, and then we can actually also save it in retrieve docs. Then we are combining the retrieved documents into context. This is very important. Although you have retrieved the documents, you have to actually combine that with the generation part to augment it. So we are actually combining with the context is equal to /n.join of retrieved docs. I'm just going to concatenate everything, concatenate all the retrieved documents. Then the prompt which I'm going to pass over here, this is the prompt template I have followed, that the context is given over here. Along with the context, I'm giving the string over here that answer the question and the query. So within the placeholder, I'm going to take the user's query. The user can ask any questions, which is something from the PDF, or if in the prompt only I specify that if it is not there in the context of the PDF, then say, I don't know. If I give that as an instruction, let's see if RAG is actually able to, RAG chatbot, which we are going to build, is actually able to do that or not. So this is the prompt template, what I have followed, that it is taking the context as the backstory and then going to answer the question by taking the query from the user. Then we are going to query the 𝗥𝗲𝘁𝗿 API for chat completion using the llama model. Like I have used here llama, but in case you don't want to go with the llama model, like I said, you can also use any other models as well. So the query with the LLM part is there in the code. Like I was saying, if you want to experiment with the DeepSeek model, right here, you just have to give the model ID of DeepSeek from the 𝗤𝗏 platform. But now let's see the response initially. So prompt is equal to, we say this is the context along with the answer with query it's going to ask the user for. Then response is equal to query with LLM of prompt. This is going to, so query with LLM is actually expecting us to pass the prompt parameter, and it's going to generate or return the response. The final response is what is going to be returned by this function. Then we are coming to the last part, which is query with LLM. We are passing the context over here. There is a logic which I wrote, which is we are going to use the 𝗥𝗲𝘁 API to firstly send the context and get the response from the LLM. So the LLM will actually be having both the context as well as the user query. So the context plus the user query will be serving as the prompt for the LLM. Now, chat completion is 𝗥_client.chat.completions.create. This is the I would say if you go to the official documentation of 𝗥 also, you would have an understanding as to, firstly, you install 𝗥 into your system. Then you will have an understanding if you want to invoke the 𝗥 API, then this is how you do, right? Then coming over here, messages is equal to role user. We are actually doing role prompting over here. So the different types of prompt engineering techniques, like I said, one is role prompting, where you are actually giving the role as well to the LLM model. Right. So here we are actually specifying role as a user, content is context, because we are actually taking the prompt from the user. We have given the role over here in the messages. Model is equal to llama3 8B. If you want to actually use an experiment with DeepSeek model, you can actually just have to change it over here. Firstly, I'll show with llama, then we can go to DeepSeek also. Then except exception. In case there is an error in this, then it will also be catched, which I've just written, error with 𝗥 API. In case your 𝗥 API is not working, for debugging purposes, you want to catch hold of that exception. Then you can actually print that error with 𝗥 API and the exception saying that, sorry, firstly, it does not generate a response and what exactly is the error. All right, so now if you want to actually build a UI for this, because this is the backend code where I've just encapsulated the functions, nowhere have I called the functions, right? If you want to call these, see this working in a UI, this RAG UI.py is the second file what I have, where I have imported Streamlit. So firstly, the UI part I'm building in Streamlit, which is a very lightweight Python framework for web application building from RAG pipeline. RAG pipeline over here is this particular file, what I've just written the backend logic. So from RAG pipeline, I'm just closing the other files. Yeah, RAG from RAG pipeline, import load documents and build RAG pipeline. So these two functions I'm going to import over here. Streamlit UI setup is firstly, if you want to give any title to your Streamlit application, you can say st.title and give RAG chatbot document query system. Then st.write in case you want any message also, like I was showing it to you in the slides. I was showing you the UI, how it looks, right? So if you want to actually give some message, you can pass this message. Like this is a RAG chatbot. It answers questions based on the documents provided. You can upload a PDF or a text file. So within the, in the UI itself, where the user will be interacting, I have given this message that either pass a PDF or a text file. And the system will allow you to ask questions based on it. File uploaded over here. So this is where the file is loaded in Streamlit. We know that st.file_uploader is basically the inbuilt function where you are actually allowing the user to browse files. Right? The user can actually have the option to upload files. So the file type can be the type. If you want to extend it to multiple different forms or different extensions, you can do that. One is PDF and TXT, which I have passed. If you want to allow the user to pass doc and docx files, you can do that over here. If uploaded file is not none, then firstly, if there is no file, it should throw an error. But if the file is there, then the code gets executed. That is, you load the document by passing this uploaded file over here. Initialize the RAG pipeline, which is encapsulated in the big, build RAG pipeline code, what I have just imported from RAG pipeline logic. And then the query of the user is asked here. So there is an input which is there displayed in Streamlit, which says, ask a question about the document to the user. If the query is true, that is, if the query is passed by the user, entered by the user, the response is supposed to be generated. And that is, you're invoking the RAG pipeline function over here, passing the query, and the answer will also be shown in Streamlit. So if you want to run your application, I'm just saying Streamlit run, and then the name of my application. This, by the way, everyone, this over here, what I'm explaining is a very simple RAG-based chatbot. Right after this, I can also show you how exactly you can build an agentic RAG. So it's a follow-up of that. Once you've understood a RAG-based chatbot, to better enhance the capabilities by giving it access to tools, etc., we can actually build an agentic RAG chatbot also, right? So I'll come to that. For now, Streamlit run RAG UI. So why am I writing run? Because it's if you are running any backend logic, then you can say Python and then the name of the file, Python space RAG pipeline.py. But right now I want to run the UI and show you interactively. That's why I've given Streamlit run RAG UI.py. Okay. Yeah, it is taking me to the UI right now. So this is how the Streamlit application looks like. Okay. I think it is just loading for a while. Take some time. But yes, meanwhile, if you have any questions related to any part of the code, you may ask me or in the chat. Yeah, any type of knowledge file, right? Streamlit doesn't work with Google Colab. All right, so actually on Google Colab, it does not work. When I had tried out, you have to use some additional functionalities like ng-rock. Through ng-rock, you can actually be able to run it on Google Colab, but that's a little complicated process. So that's the reason I would prefer going with Visual Studio Code, PyCharm, or anywhere locally in your system, so that, just for the Streamlit application, you can actually see it working. Okay, I think it is loaded right now. Says in my backend. Yeah. So this is the interface. As you can see in my UI, I actually have, it is asking me, saying it's a RAG-based chatbot. Whatever message I was showing it to you in the VS Code, the same message is displayed over here. And you can ask any questions. So I see the option to upload a file. I can go to my file section. And I see maybe I can ask it about pollution. Yeah. Now, once it is done, the document loading was happening in the backend. Once it is done, it will ask me to ask a question about the document, right? Now, you can ask me, you can ask the questions. You can prompt it with any query saying that as per the document, you can specify it's as per the document, what are the causes of pollution? Or you can say, what are the ways to prevent pollution? This is my query I have passed, and it says the answer that according to the context, the document mentions. So don't you see this way? It is actually grounding the response. We are helping RAG chatbot to actually ground the response, only giving relevant questions from the document. It is not hallucinating or using its generic responses. We want something from the document. That's what we are getting. And the good part, I have also implemented an agentic RAG, some document where you can actually source it as well. Whatever the answers which it is fetching, if you also wanted to source the relevance, or you also wanted to source where exactly the paragraph is taken from, that is also available. So that I can show it to you, that how can you actually integrate tools with the RAG chatbot to make it, take it to the next level. Right now, it's in the prompt which is doing the magic. Firstly, prompt is playing a good role here, we have understood. And also, it's a RAG, essentially the document which you have additionally provided, so helping it to ground the response. So you can see according to the context, the document mentions prevention and control of industrial pollution under the topic of control such pollutions. So it's actually giving us a topic also in my document, in my PDF file, where exactly it was present. This implies that the ways to prevent pollution were, okay, then it's also talking about implementing emission to particulate matter from industries. To achieve these measures can be taken such as ensuring regular maintenance, etc. So it's also, it's just giving us the answer, what it has found from the document. Now, if I ask it something which is not there in the document, I have given it a document like environment pollution, right? Now, if it asks it a very, vague question which is not there in the document, and I still specify saying as per the document. So if I say as per maybe the given document to be more specific, and then if I give it here a question like what is, let's ask a question, something out of the context, something like what is deep learning? Okay, this is not there in the document. Let's see what the chatbot will do. I apologize, but the provided document doesn't contain any information about deep learning, right? So this is exactly how we are helping the chatbot to actually ground its responses and give relevant, responses, pulling or retrieving, relevant information from the document we have given. So this is the way in which RAG chatbot works. I hope everyone has got an idea as to how RAG works and how exactly the retriever generator component works, and you were able to implement this successfully. If not, I'll be sharing it right here in the chat, the files to you. But I don't see any link actually to upload the files, but no worries, it will be sent to the team and they will be sharing it to you, the reference files. So any queries so far, anyone, on any? We have seen the most, implementation, the very basic, simple implementation of a RAG-based document query system using various frameworks. And if you want to actually implement it and take it to the next level, like I said, also allowing you to source or cite what the answers are from your document. It is very helpful in research papers or in legal documents when you want to cite the references from the document. Then there you can actually use the agentic RAG. So any questions so far in this? Okay. Yeah, I'll get to the code where I've applied agentic RAG. Right now, this what I've shown you right now is not agentic RAG. It is simple RAG implementation. I'll come to that as well. Okay. I'll be sharing the code of utility.py. Where exactly utility.py? This is RAG UI.py, right? Are you actually, you want this one? RAG UI.py is for building the Streamlit application, the front end part. RAG pipeline, these are the only two files I was explaining. RAG pipeline.py is for the backend part, and RAG UI.py is for the front end part. So I'll be sharing, as I said, I'll be sharing the codes along, everything to the team, the materials to the team so that you can refer. Collapses FAISS code, can you please explain? Or what exactly is your question? Like when you're actually, you have imported FAISS, right? FAISS. So import FAISS, and here is where I have used FAISS, right? Okay, this is embedding part. Document loading. I have used FAISS over here. Yeah. So while I'm building the RAG pipeline over here, I was initializing FAISS for efficient similarity search. So this is where I have the embedding dimension captured, where the embedded documents or shape at one is going to give me the dimension, and then FAISS.index to index flat L2 will basically pass in an index. So index I've just added so that it makes it efficient retrieval. If you want to see, it's like a vector store retrieval. If I was showing you to you in the slides of mine, I showed you that here is a vector store retriever. So if you want to get the retriever component to better semantic search or through an index, so you can actually add an index. It's an inbuilt function, what I'm using over here, like face.index flat L2 and add. These are built-in functions in Python. So that is what I'm using over here to do the semantic search or to apply the semantic search on the FAISS database, on the documents present in the FAISS database. Okay. Now, if this is clear, I will move on to the more interesting part, which is agentic RAG. Right now, this is also one very interesting term, widely used, like agents and everything. But we're actually talking specifically about agentic RAG, not agents in general, but agentic RAG. Now, what's happening over here is it almost looks same. This just one single file. Now, what it does is I've integrated the front end and the back end in the same code so that, there are no, like, it's very easier for you also to understand. So firstly, I'm importing Streamlit as ST. From LangChain.chains, import Retrieval-QA and LLM chain. So LangChain is a framework what I'm using over here. And it is, like I said, end-to-end orchestration framework, which helps you to do the retrieval part, the generation part. It also has an agent component. LangChain itself has an agent component along with the tools and memory module. So what I'm doing is from the chains package, the chains library of LangChain, I'm importing Retrieval-QA and LLM chain for building the chatbot. So from LangChain.prompts, so I would also request you, if you want to implement agentic RAG, please do. I will just pass in the requirements over here. LangChain community. So pip install LangChain community and LangChain grok. For now, these both should do. All right. LangChain community and LangChain grok. These are the two, libraries for now. Additionally, you don't need to install anything because everything is covered, like Streamlit, FAISS. If you have done that, then no need to actually worry about anything. Right now, it's LangChain community what you have to install, and you have to also install LangChain grok. All right. In case you already have grok installed, it should be fine. Then from LangChain.chains, you import Retrieval-QA LLM chain. From LangChain.prompts, you have to import chat prompt template, human message prompt template, and message placeholder. These are essentially for, see, it's very important that you instruct the LLM prompt template to follow. It's like a sample prompts that the LLM can actually take care of, so that if the user does not give it something accordingly, it can actually do the formatting as per the prompt template. Right? If you want the context to be there or the memory to be present in the prompt, that all can be handled via prompt template. And this chat prompt template, human message prompt template is actually imported from LangChain prompts only. All right. Then from LangChain.chains.conversation.memory, we are importing conversation buffer window memory. Like I said, it's very important or very helpful also to actually have a memory component in chatbot, because if the chatbot is having memory, they can actually retain the context and the previous information. That's the reason I'm importing the conversation buffer window memory from LangChain.chains conversation memory. Let me close this for now because I'll be running the other stream, this file. Okay. Now from LangChain grok, I'm importing chat grok. And from LangChain document loaders, import PyPDF loader. In the previous case, I was not using PyPDF loader. I was using FAISS library, right? Right now, I'm using PyPDF loader over here, which is imported again from LangChain. So everything what I'm actually importing for this agentic RAG, what I'm showing is actually from LangChain only. All right. So from LangChain document loaders, import PyPDF loader for PDF handling and processing. From LangChain.embeddings, you import Hugging Face embeddings. Now the question was, you were also very keen to explore the different embedding models, right? So there are three, like I said, OpenAI embeddings also one, but that requires an OpenAI API key, which for now I'm not going with. I'm going with the open source version of it, which is Sentence Transformer and Hugging Face embedding. So I'm importing Hugging Face embedding from LangChain embeddings and from LangChain tools. Like I said, the memory component is there, tools are there, and other prompt template. All these are the various components present in the LangChain framework. So the tools component over here, I'm importing DuckDuckGo search. Like I said, tools is basically like an external access which you're giving to your chatbot. Now, though the chatbot is not just limited to document, it will have an additional tool. And what is that tool? That is browser-based search. So DuckDuckGo search run over here. This is a library which is helping the chatbot to actually have web-based search. It has the capability to go search the web browser in case the the question what the user is asking is not there in the chatbot, is not there in the document. Like in the previous case, the question which I asked was not there in the document. It just simply said, it is not there in the document, I don't know sufficient information. But if you want to avoid that, you want to give some additional capability to the RAG chatbot, saying that go access the tools or go search the web also and retain me the relevant information. For that, I'm using import DuckDuckGo search run from langchaincommunity.tools. All right. So I hope this all is clear to you, what I'm importing and why I'm importing. Import OS from load.env, import load.env. Load.env is a library which is helping you to fetch your Grok API key. That's it. Because in your .env file, you don't have anything apart from Grok API key or any token. So as of now, we are importing load.env from .env. Then I am calling this function. Here is, again, like we know, in the RAG pipeline or in the RAG methodology, the very first is loading the PDF. Document loading. Okay, simple step, which is document loading. So document loading, I've written over here the function where I'm loading all PDF files from a given folder. So the folder over here is right now documents folder, where I have 3 PDFs: environmental pollution, and something about tourism. Okay, tourism and the 2 documents are about pollution. Okay, now you can have any number of documents. You can have some 20 documents also. That's completely fine. For the demo purpose, I have shown with 3 documents. Then what it does is I'm having this documents list initialized as empty list. I'm writing the logic. Just like in the previous case also, I have written a custom logic of mine, which will be firstly accessing that particular directory, and then we'll be checking if that document what I have is in the PDF form or not. So if the file name ends with PDF, I'm going to filter for PDF files. Loader is equal to PyPDF loader. So instead of using fits, I have used the PyPDF loader over here for reading the PDF from the file path. Then documents.extend of loader.load. I'm adding all the documents from the PDF. Right, so the PDF is there, but then there are definitely the any files which are there in the document. All of them will be actually read. So this will be stored in the documents list over here. I'm returning the documents. Then I've written a simple main function where the entire logic I've just written over here. There is this one function I've written for loading the PDF from the document, and one main function or the driver program, which is actually going to do the logic of showing it to the UI. That is through the Streamlit application, and also invoking the chatbot to actually start thinking or go access the tool. Right, it will actually give the ability to the chatbot to fetch the resources from the tool, that is from the web-based search. In case there is no context or no specific information, it is able to retrieve from the document. So it has both access to the document understanding is also there, along with that the tool understanding is there. So I've written over here st.title. This is just for giving a title for the Streamlit application. I'm writing it over here, a message for the user, instructing the user that interact with the agentic AI RAG chatbot powered with LangChain with added browser search and document retrieval features. Right, so any special document retrieval as well as the browser search features. Then st.sidebar.title settings. In the sidebar of my Streamlit application, I'm having the settings where the user has the ability to actually choose what is the model he wants. Also, I was talking about the DeepSeek model, right? So let me quickly add the DeepSeek model over here also. I just forgot on that part. 1 second. Yeah, I think it is models. Yes, in models, you go to the DeepSeek, in the preview models right now, you have to just copy this ID over here, which is DeepSeek R1 Digital Llama model. This over here, I'll be adding it as a 4th model. Okay, in my code, I'm just adding over here in the 4th model in the models list. Okay, done. Then over here in the settings section, the user has the option to actually choose what model he wants to go with. So here it's not just Llama, he has the option to go with Mixtral, Gemma model by Google, or even DeepSeek model, right? Then memory length is if you want how much memory to be retained on a scale of 1 to 10 as a sidebar slider. I'll show you also when I implement how it is looking. I've just added a component as a sidebar that the user can actually have the option as to how much threshold of memory can be retained by the chatbot. So on a scale of 1 to 10, the default value over here I've given as 5 in case the user does not even select anything. Then initialize the conversation memory. I do want the memory component to be retained by the chatbot because I don't want the chatbot to forget the past conversations or the previous interactions what we had. So I had added a conversation buffer window memory where I've given the memory length which is taken by the memory length component by the slider, the user whatever he sends. By default it is 5. Memory key over here is chat history, and return messages is true. The user input is over here, ht.text input of your message. We are going to pass as a user the message to this via the Streamlit application. Then I'm going to check here if chat history is not in st.session state. In case the session history is not there, then it's going to previously load. It's going to load the previous chat history into memory. In case there is no memory or chat history reading, because we do want to ensure that whatever we have asked the chatbot previously, that also should be serving as a context to the chatbot. That also should be serving as a backstory. That's why we have loaded that. Then memory.save context, I'm passing as a dictionary over here. Input, which is the human message from the message from the human, and then the output, which is a message by the AI. The role prompting, basically. Once that is done, initializing the Grok chat model. How am I doing that? Chat Grok. Earlier, I was doing it by the client. There are different ways to do it. Earlier, I have done it by a Grok over here. Grok and then API key is Grok API key. Here, I'm using chat Grok model, and then in the Grok API key, passing the Grok API key. Both are almost same. I'm just initializing the Grok chatbot model over here, just like I have done for the Grok client. Then I'm passing the model name as well. The model name will be taken from the user only. Like whatever the user selects in the Streamlit application, via that only the model would be passed over here as an argument to ChatGrok. It will get initialized. Once you have initialized the ChatGrok model, initialization of embeddings is super important. Why? Because if your embeddings are not generated, you won't be able to actually proceed further, right? With the documents, you won't be able to do anything. You have to generate embeddings for the document. So we are using Hugging Face embeddings over here for generating the embeddings. The model I'm using over here is sentence transformer again, all mini L6V2. Then load multiple PDFs from a folder. So from this folder document, I'm calling this function for loading the multiple PDFs what I have. So this documents folder has 3 PDFs. In your case also, you can have a document section, a document folder where you have all the multiple documents stored. This is just, I was doing it for my backend testing. Like I did not actually send it to the front end. I was doing it for my backend testing. But then if you're doing it directly from the front end, you need not specify the folder path at all, because that all will be taken by the user. Whatever the user is entering or will be uploading, the files he will be uploading via the UI, those files only will be directly fetched, loaded by the system. So right now I was doing the backend testing. So I have added these lines also. Then docs is equal to load PDFs from folder, vector store. So FAISS over here is a vector database. Here also I've used FAISS. As I said, there are multiple other ones also like Pinecone, AstraDB. You can go with LansDB, or you can go with ChromaDB, etc. For now, FAISS.from documents, docs, embedding. So I'm passing over here the documents which are nothing but the loaded PDFs from the folder, and then the embeddings also. The embeddings which are the Hugging Face embeddings which are generated. Now, retriever component is what is getting activated. So vector store.asRetriever, I'm calling the asRetriever function over here. And then retrieval QA chain is equal to retrieval QA. This component is taken from Hugging Face only. So if you see over here, retrieval QA, it is basically the retriever component of LangChain. So I think I have imported it above. Yeah. So from LangChain.chains, import retrieval QA and LLM chain, right? So this is basically the retriever part, which I'm a retriever component of the LangChain, which I'm fetching it over here. So retrieval QA chain is retrieval QA from chain type. LLM over here is Grok chat, which I'm going to assign. So based on whatever the user selects the model, that will be assigned to the LLM. Retriever part is over here. Return source documents is true. This is also very important. Why? Because like I said, in Agentic RAG, I also wanted to cite the documents. Also wanted to cite as to whatever the LLM is telling, whatever the LLM has given the response, from which document or which exactly the part of the document or which document is actually being fetched from. For example, you have 100 documents in a folder. Now, it makes sense to actually understand as to which document out of those 100 are actually the ones which are relevant, from which the LLM application has actually retrieved the answer from. That's the reason I have return source documents is true over here for retrieval QA from chain type. So once I have passed all these arguments, the parameters to from chain type, I'm initializing the browser search tool. Documents is one side. Now, what about the search tool? Search tool, I'm invoking it by calling this 𝗥𝗲𝘁 run. I've created an object or instantiated it from this class. And then if user input, I'm defining the chat prompt template over here. This is also from LangChain, which I have already imported above. Chat prompt template from messages placeholder, I'm passing the chat history and also passing the human input. the human message prompt template. Once the prompt template is also defined, the interesting conversation part comes in. Then here the conversation is being kicked in. So you see here, you're creating a conversation chain by using the LLM chain component, right? So LLM chain over here is a function which is expecting you to pass these arguments. Firstly, the LLM name, which is taken from the UI only, prompt, verbose, if you want the LLM to be more verbose, as in more, more descriptive in its responses, then you can say verbose is equal to true, else false. Then memory equal to true if you want the chatbot to have or retain the memory also, which is important. Along with the memory, we also want prompt also. So prompt also is passed here. Now, what is chain? What is the chain component doing? Like the word says, LangChain. LangChain is basically, as I said, it's a framework to chain or basically to glue together our prompt along with the LLM. So it's basically connecting or linking the prompt to the LLM and the memory. That is what LangChain is doing. And that component is the LLM chain component, which is actually connecting the user's prompt to the LLM along with the memory or the context. Now comes the handling input parts. If the user if the user's query starts with something like search, then if the user says something like search, and then if he says search about attention mechanism, then it will start searching on the web browser, and then the results will be returned over here in the Streamlit UI. The logic also have defined over here where query equal to user search, user input dot split search, because search is the first word what the user will say in the prompt. If it is starting with search, then any white spaces will be removed with strip, and then search tool.run of query. The query will, so basically this tool will start running by taking in the query as a prompt from the user and will be invoking the DuckDuckGo search API. Now, the DuckDuckGo search is also free. You don't need any API for that. It's a web-based browser search. Elif retrieve. So in case the user says something like retrieve and then gives a prompt, then this logic gets executed, which is basically results are fetched from retrieval QA chain.invoke the query. So this is an inbuilt function. You can take this is a boilerplate code for you where you can follow the invoke method over here. The query is passed to the retrieval question answer chain, and then it is acted upon. So it is not only going to display you the retrieved answer from the document as a result, but will also cite the document, as in from which PDF, which particular PDF is the answer, relevant document actually fetched. So that is also there over here, doc.metadata of source, which is there in the source documents. Now else, in case the user does not say anything starting from search or nothing, does not say anything like retrieve, then the regular conversation is also included over here, which is response is equal to conversation.predict. I'm passing in the human prompt over the user prompt over here, and then in the chat history also is appended with the human user input along with the response. That is, when you're saying that the context or the history is appended, it means that it's not just the previous queries of yours which are appended, but it is also the previous responses from the LLM which are taken into account. So the previous LLM responses as well as the previous user query, all of them are taken into account, serving as the context for the past conversation in the memory module. So st.write, you're finally going to print the response of the chatbot. This entire script will run, I wanted to do it in the backend also. So I've written if name is main function. Else, if you want to run this in your UI, then you simply can say streamlit run, the same code, streamlit run, agentic rag. So I'm just giving the name of the file here, agentic_rag. I'll show you this demo also in action. I'm closing the previous one. Yeah, so this is what our application looks like. RAG agent with browser search and document retrieval. It's asking us to actually give us a message, and we'll be using the LangChain for the application. So this is the memory length, like I was talking about. 5 is set as default. If you want to set the memory length 3 or 10, you can actually increase it accordingly. For now, let's set it to 5. Choose a model. Here I have DeepSeek added also, right? Like let's experiment with DeepSeek. So here firstly, this is the message, the system prompt, and then the DeepSeek R1 Distill Llama 70B model is what the user has selected. Now the message. Let me start with retrieve, okay? Because I want retrieval part to be getting activated in the RAG pipeline. So I'll say retrieve. Now when I say retrieve, I'll say the documents are already in the folder, right? The documents are already there in the folder, and the documents I have right now, like I said, you can have any number of documents, but right now I have an environment pollution, and the tourism document. So right now I'm asking it over here, retrieve. Okay, I did not ask anything, so it just was quick enough. But then now if I say retrieve, what are the means of travel. Okay, because I have a travel and tourism PDF also. Let's say if it is hallucinating or it is giving me the correct answer. I have given it retrieve. And I'm using the DeepSeek model here. It is running. DeepSeek is little slow because it is actually reasoning also. Yeah, you can see here. It says I need to figure out what the user is asking. They provided a context about tourism, travel, and transport. The question is, what are the means of travel? Let me go through the context to find relevant information. So, it is actually thinking. Because DeepSeek has this reasoning ability, it is actually thinking just like we do. So it's saying that the user is asking this, let me go to the document. It's actually telling that. Then it is saying first the document defines travel as moving from one place to another. It's talking about this. Then it's also saying that I look for sections that talk about transport. It is saying what section exactly. Then it comes to the question, the main point, that is means of travel include. Because I said, what are the means of travel and tourism? It is actually telling that. I think that's all the information provided. So it is not hallucinating. It is actually giving us the responses from the its responses from the document we have uploaded. It is saying that the means of travel mentioned in the context include, all these are the context, and it is also citing us the source documents. Don't you see it is wonderful and amazing to actually see that the source documents are also there? Like expected, it will not throw us that it is citing from environmental pollution. Like if I show you in my documents folder, there is environmental pollution, and introducing tourism. Right now, it is not hallucinating. It is just giving us introducing tourism PDF as a document, and it is correct because it is not citing the wrong document. So citation is correct. Along with that, it is also given as a step-by-step reasoning. Step-by-step reasoning, as in it is actually following the chain of thought kind of approach, and it is giving us a means of travel from the context of the PDF. Now, if you want to experiment with a different one, like let's say a different model, like let's say Gemma, and here in the last, this is the last part, then I will come to the doubts. If you want to experiment instead of retrieve, we can first try. What are the causes of pollution? Enter. Now, when I say retrieve, right, it actually will be retrieving us the relevant documents from the documents list. It will not hallucinate. Let's see. Yeah, retrieved answers. According to the text, pollution is caused by so and so. The text includes these examples, and also the citing is correctly. It is citing as environment pollution and pollution. Do you see any travel and tourism here? No. It has not given us any answer from the wrong document. So this is also correct approach. It is, we can say that it is actually working perfectly. One last thing, and we can conclude. What if you want to say search? Now, because I have added the logic in my code, that it is not just restricted to retrieving the document, but also an additional functionality, which is the search component. That is, it will go and connect to the DuckDuckGo search web browser to give us the relevant results. So the search query, if I say here search, okay, keywords mandatory. 1 second. All right, I think I just go ahead. Is it correct approach what I'm following? Yeah, I'm starting with search only. Okay, let's see. What is deep learning? Okay, this is something which is not there in any of the documents. Let's see, it should run. I tested it. Yeah. So I think probably because I've given it a break and I did not give any question to it, it was fast enough. But then now if I say what is deep learning, it is giving me an answer from the search results. Though it is not there in the document, it is giving me an answer from the search results, right? So don't you see, this is actually amazing. It is actually giving me the answer. Even if I ask it something like what are the causes of pollution in the search, it will not give me answer from the document. It will give me answer from the tool, from the web search tool. Like DuckDuckGo search is one tool. You can also go with many other tools which are available and connect it with the LLM. So that's about RAG and concludes the session. I hope you have found it insightful. Let me just check on the final part. Yeah, so that I think that should be fine. Any doubts, anyone?
Yeah, I have a doubt.
Okay.
So in your agentic RAG code, can you go to that code? Can
Sure.
you like briefly break down this code into the different agents that are into play in this?
Okay, got it. Sure. So firstly, I have used LangChain framework over here. LangChain is the framework which is actually having the agent. There is no multi agents, I would say. There is a single agent for now, what I've used in my code. But then So LangChain is the agent. Now, if you talk about the tools, the various tools what I have used DuckDuckGo search, which is a tool for the agent. Then there is a memory component, which is conversation buffer window memory. All right. So if I just scroll down over here, let me just check if I have any other component. Yeah, I have retrieval QA and LLM chain. What is it doing is basically connecting the prompt of the user to the LLM. So that is acting like the chain over here. So I will just scroll down. You can see firstly the document loading part is happening, the very first component. Once that is done, the main core will actually have the LangChain in action, where you have the conversation buffer window memory. So this memory component is the first component to keep in mind. The second component over here is the API key as it is. We are just loading that. The second component is the embedding generation component, which is happening from the Hugging Face embeddings. Like that is also one thing which is not specific to LangChain apart from memory. Then we have FAISS, which we are using over here. That is again external database, so nothing to do with the agent, nothing to do with LangChain. But then it is the component of the agentic RAG, the vector database component, memory component, tools component. Then you have the LLM. Okay, I hope these are clear to you. Tools, memory, LLM, and the vector database. So these are the four components of any agentic RAG system. So here we have retrieval QA chain, where we are actually building a chain of components. We have the LLM over here, the retriever part, and then finally the return source. If you want the return source, this is a parameter what I'm passing over here to retrieval QA over here, because I want the documents also to be cited appropriately. So that is why I've passed it here. The search tool over here, which is DuckDuckGo search run. This is also component taken or imported from LangChain itself. Then I'm checking if the user query over here is starting from search. If it is starting from search, I'm calling DuckDuckGo search here. If it is not starting from search, it's starting from retrieve, I'm doing the simple RAG. The simple RAG base, which is taking the document, retrieving the relevant information of the document, and enhancing generation capability. That is what is happening. Else, if the user says something, nothing starting from search or retrieve, a general conversation, that a generic response, either from the document or from the tool, can be actually given by the chatbot. So this is, I've just used one tool over here, but like I said, you can have access to any number of tools. If you want to use Wikipedia, or if you want to use YouTube API, you want to use any other external API, you want to connect to your LLM, you can actually import that over here and connect it in the tools framework.
So just to add one thing here, the main agentic thing here is that based on the user question, right? Now user can ask anything. It is not always true that user will ask a question based on document, right? This particular agent will determine from the question that if that question can be directly asked using RAG, or it needs to search through some like here we are using DuckDuck run, but there are multiple methods to do search, right? So based on the question, it will determine whether it can answer directly or it searches somewhere and then provide the answer. So that is the agentic part here, like if someone is having any confusion.
Oh, so just to be clear, what makes this an agentic RAG, and how is it different from a normal RAG?
So in normal RAG, what happens that you always try to fetch information from a document, right? That suppose a document is consisting of environment pollution and you are asking a question related to politics, right? Now it will by default try to seek answer from there. Here what is happening, that if that question is not contained in those documents, right? Now what next? So what the next is that you give it a method that, okay, it will search somewhere else. So that is the difference from a normal RAG.
Okay.
Absolutely.
Yeah. Got it. Thank you. I have one more question about Grok client. So in the previous program, not this agentic one, so you use Grok client. So can you can you go over it again? Like how is it different from what we used in the recent program?
This one. So here I've actually instantiated an object of ChatGrok. Actually, ChatGrok and Grok, both of them are LLM providers for doing the inference. So both of them go similar. Let me just check where I have used ChatGrok here. I can show the comparison. So yeah, so I've initialized the ChatGrok model. I'm writing Grok chat. This is just a variable name I have given. I've given the variable name over here as client. I'm just calling it as client, which is nothing but an instance of the class itself. I'm using here Grok and then API key. I'm passing as a Grok API key. Here, instead of Grok, I have passed ChatGrok. Because over here, ChatGrok is actually, if you see in my import statement, I have imported ChatGrok from LangChain Grok. Whereas here, I have imported Grok from Grok library. That's the only difference. So in one case from LangChain, because this agentic RAG have completely used all the components of LangChain, so even including the chat Grok. So this chat Grok library is actually imported from LangChain Grok here. So that object only I have instantiated over here just by writing, Grok chat is equal to chat Grok and then passing the API key along with the model here. In this case, I have not done that. I have just used from Grok import Grok and then I have passed the API key to the RAG. Is this clear?
Yes. So that's the two ways of doing like using chat. Oh,
Correct. Grok, absolutely correct.
And
just do it via LangChain or alone. Yeah,
just one last doubt. Can you go over chat history wala section once again?
Okay, chat history in agentic RAG or in RAG pipeline? I think it is.
It's I think in the agentic RAG.
Yes. So in agentic RAG, I have also added the memory component over here because that's also an important component of agent. So what happens over here is you want the past information to be retained. Firstly, this library, right? Conversation buffer window memory. This I have imported from langchain.chain's conversation memory. So if you go over to the official docs of LangChain, you will see that this library already into picture, like the prompt template, conversation buffer window memory. Now, if I scroll down over here in the chat history, I think over here, when the user is passing the prompt, that is fine. Okay. Yes. So in the regular conversation, in case what happens is if the conversation will predict human input. Once the prompt is passed without the search or the retrieve, then I have added a state or session state or chat history. I think you're asking about this, right? So chat history over here is basically, this is for the Streamlit application. In the Streamlit, if you want the chat history to be retained, there is this inbuilt module, which is chat history component of session state, where I'm appending the human prompt, what the user has asked, along with the previous response of the RAG pipeline, of the RAG chatbot. So that is what is there in the chat history module. I think I have also used, other than this Streamlit application over here, I have also used chat history somewhere else above. I think I have, while explaining, I did that. Yeah, here. So if you see over here, the chat history, I'm initializing the chat history in the session state. So here is where I'm doing. If chat history not in the session state, then I'm just giving the sessions chat history as an empty list, because it is not there in the session state. Else, if you want to load the previous chat history into memory, if you want to do that, then I've written a logic here, where for message in st.session state.chat history, I'm looping over all the previous messages which were asked by the user in the session history of the Streamlit application, memory.save context. So this memory.save context over here, if you see memory component over here is from LangChain. This is an object which I've taken from the conversation buffer window memory. I'm passing the memory length. What is the memory length? Memory length is right here, which is taken from the Streamlit application. This is the memory length. And then I see memory key is the chat history and return messages as true, in case you want the messages to also be returned. Then in that case, I've given us true here. So once I have the memory variable, I'm looping over that. So for message in session history, chat history, memory.save context is how you can actually save or load the previous history of the conversations also, by having both the input, the human message which the user is asking, along with that the output of the AI bot also. All right, that is how you're actually loading the previous chat history into the memory.
Okay, thank you so much. What is session state? Can you repeat that?
Session state. Okay, so st.session state is actually a component. Just like in Streamlit, you have sidebar, right? st.sidebar component. There are different types of GUI components available. So session state is a component in Streamlit. You can have a look into the Streamlit docs also, that well explains about it. I think right here you do have the session. If you just deploy your application, there will be settings, clear cache. And there should be one session state. Basically, session state is a component which will store the previous memory into the Streamlit. So once your session is done, this is one session. The moment I close this, right, and if I rerun the session, if I redeploy that, I rerun the session, if I go to rerun over here, then on clicking on rerun, it will activate a new session. So a new session history will be generated. So session is like, even in Google Colab, you might be aware of this session, right? You have one session where once your Google Collaboratory is disconnected, you have to activate the kernel, or a new session gets started. So that is exactly what a session means. That particular duration when the application is running.
Okay, thank you so much.
Thank you. So I hope that is clear for everyone and you have found the session quite interesting.
So please feel free to ask question if anyone has. Uh, you can put in chat box or you can just raise your hands and you can ask. In the future session, we'll be covering, there are more topics. Like for example, in this session, we just saw the retrieval part, but what if your retrieval is not good, right? So there is a thing called performance as well, the performance, your RAG, those things we will cover in future, and more advanced concepts in generative AI we will be covering. Rest you can find, we have more sessions uploaded on our YouTube channel. You can just go to the live section and you can check there.
So, hi Sundarat, I have a question.
Yeah, sure.
So, you did a Google search for deep learning, right? In the session.
Yes, I've done that.
So, can you restrict that search to only to pollution? Can you show that how can we do that?
To only pollution, like something like what is pollution?
Yeah, only related to pollution, not off the topic search.
Okay, not off the topic, sir. Then in that case, you have to write retrieve here. If not the off the topic, you only want it from the document and not off the topic, then you have to write retrieve what is pollution. Now, when I run this.
No, I want to the website, not from the document, but from the web.
Okay. From the document, it is happening. From the search, if you want to, from the web search, then you can do search only, right? You just say search and what is pollution. That will do web search.
I mean, can you constrain it?
Constrain it to what exactly? Not to web search?
Yeah, you have to do the web search, but only to pollution. It may
Yeah,
not
it is
search.
doing, yeah, it is only doing pollution, right? It is giving us the web search. Okay, you are saying only to pollution topics. No, it is actually doing global web search. When you say web search, it is actually going to search on the web, just like we as users are searching on the web. But what is your prompt? You have asked what is pollution. Just like on Google search engine also, you ask what is pollution. The most relevant pollution information gets popped out, right? Same way you are asking over here, search what is pollution. It will give you the search results. Now, if I remove search, if I just say what is pollution, still it will give me the answer. Let's see what it gives. I'm removing retrieve, I'm removing search. Still, it will be able to fetch me the answer. It says pollution is the introduction and it's the breakdown. So it's actually giving me the answer over here. Regardless.
So this answer is coming from search or it is coming from PDF?
This answer is coming, yeah, this answer is coming right now from search. I mean, it has the enhanced capability, like I said, in the code also. If the user does not specify a retrieve, let me just have a look. The user, okay. It is coming from conversation.predict. It's coming from the LLMs pre-existing. Neither from the search, nor, yeah,
yep.
Pre-existing memory, correct. So LLM already is trained. It's a pre-trained model already having some amount of information, right? Like just like ChatGPT. Same way, we are not giving it search, any DuckDuckGo search, nor document. It is just giving from its existing knowledge.
Yeah, thanks.
All right. Yeah. All right. Thank you so much, everyone. I'm glad that you found the session informative. Could you please, how hallucinations come here? What are the ways to understand it? So hallucinations are basically when the LLM is, just giving you a response which looks factually correct, but it is out of context. It's completely out of context. It keeps on giving you some gibberish results, which is not relevant at all, which is not coherent, clear, or relevant. In that is called as hallucination. If you want to curb that, you can use RAG, because RAG is essentially grounding the response, right? It is helping your LLM to just stick to what is there in the document. If you want the LLM, and that way only it is augmenting the knowledge of the LLM. So that is how you're curbing the hallucination part. If you want to further do that, because LLMs are, they're ultimately the Gen AI models, and they do have this tendency of hallucination. So if you still want to avoid that, one way is agentic RAG, what I've just shown you, one approach where you have the tools access to enhance the capabilities. Another way is prompt engineering, where prompt itself is playing a critical role, where you as a user are giving over here in the instruction that if you don't know something, just say don't know, don't hallucinate, or you don't make up the answer. If you give that in the prompt itself, that will guide the LLM, give it more context. So that is one way. Another way is fine-tuning. Now, fine-tuning is basically, there are different ways. Like if you want to do low-rank adaptation, LoRa, that is basically you're using the pre-trained models weights, but just customizing or adapting the model on domain-specific data. That is called as fine-tuning. So these are different ways of preventing hallucination. Yeah.
In
So I
in
hope
short,
this is
basically here in RAG, if you want to check if your answer, let's say, does not lie in the document and still it is giving some different answer, that is also a part of hallucination. But those things we can discuss in a separate session. This was just an end-to-end introduction how to use RAG and the performance hallucinations. Those topics we can discuss later. Yeah. So thanks a lot, Simran, for taking out the time today. I hope you guys found the lecture helpful. We'll provide the code and the PPT, everything in a separate GitHub link, and you can find the video on our YouTube channel. I'll also post a small feedback form. So do provide your feedback related to the session on that. So thanks everyone for joining to the session. We'll see you in the next session next week.
Thank you, Satvik. Thank you, everyone. Bye.
Hello.